Okay, hello everyone. Thank you for joining. My name is Sam Presley and I'm a technical product manager at Nordic Semiconductor. Today I'm going to talk to you about the nRF54L series and what this brings in terms of extending battery lifetimes for battery-powered wirelessly connected products. We're also going to touch on Bluetooth channel sounding, which is a new and exciting feature in Bluetooth Low Energy to enable distance measurement in a standardized way. So first off, going to talk to you a little bit about Bluetooth Low Energy. I'm sure many of you are aware of it already, but Bluetooth Low Energy has now been in the market since around 2009, and it is centered around low-power, battery-powered products requiring relatively low amounts of data, and is now widely adopted in PCs, phones, and many other devices. Also integrates a lot of security features to ensure that the communication over that wireless link is secure and can't be intercepted. The kind of products that we see Bluetooth Low Energy being used for, things like keyboard and mice, wearable products, asset trackers that are used to find your keys when you've lost them, as well as medical products, and many, many more, including the smart home. So Nordic Semiconductor, Bluetooth Low Energy is a really big thing for us. So we're a global leader in low-power wireless solutions, including Bluetooth Low Energy. We have a wide portfolio of wireless SoCs, and then also support this with software solutions to enable you to get your products to market and use our devices. We also now provide a number of power management devices to help you extend the battery lifetime of your products and manage the power in your systems as effectively as possible. And in Bluetooth Low Energy, we have around a 40% market share of all new registered Bluetooth Low Energy designs. So that gives you an idea of our position in the Bluetooth Low Energy market. So Nordic really has grown with Bluetooth Low Energy. We started out as an ASIC design company, and then we were involved in the early stages of Bluetooth Low Energy when it was Wyberry. We worked together with that project with Nokia, and then Bluetooth 4.0 was adopted, and really we've grown from there. And now we support much more than just Bluetooth Low Energy. We have solutions in cellular as well as Wi-Fi and also power management, as I mentioned before. So really, the key to this was the standardization of Bluetooth, which enables interoperability. Now, the great thing about this is that you can build a Bluetooth Low Energy product and rely on the fact that there's many products already out in the market with Bluetooth Low Energy support. And therefore your product can work in a seamless way with all of those devices. What we did at Nordic is we combined a 2.4 gigahertz radio together in a single chip with an MCU. So here we have a basic visualization of our nRF52 series, which is our most popular series of Bluetooth Low Energy devices up until now. And with this device, many customers have gone into production. Many of the most popular Bluetooth Low Energy devices have been built with Nordic and built with the nRF52 series. And this really enabled customers to achieve long battery lifetimes with relatively simple design in a very cost-effective manner. So what we see now is that customers are trying to do more and more with Bluetooth Low Energy. So we're going from the relatively basic applications that started out, so things like keyboard and mice, and into far more advanced technologies. So in VR, we see it being used for more advanced controllers requiring very low latency. Smartwatches becoming more complex, doing more on-device processing and wanting to transmit more data. We also have here a smart ring. So this is a great example of where power consumption is really, really important. So here, we're trying to get the batteries as small as possible. And then also the smart home, there's a real boom here in this sector, not only actually with Bluetooth Low Energy, but also other technologies that you can also support on our chips, like Thread and Matter. And then also in medical sensing, we see more and more done here now. There's a lot of innovation happening in the wearable medical space. Again, choosing Bluetooth because of the low power consumption and the very cost-effective solution that you can build. So when you look at all these kinds of products, and I'm sure you all as product makers understand this, that there always needs to be choices that need to be made in terms of what you optimize for. So whether that's size, cost, feature set, power consumption, and of course the development effort that you have to invest as a team. But ultimately, battery power battery-powered products, there's always a push for longer battery lifetimes. And at the same time, customers want more features, lower cost, and a smaller form factor device. And therefore, low power consumption really is a critical enabler for battery-powered, wirelessly connected products. So today I want to talk to you about the nRF54L series. This is Nordic's next generation of Bluetooth LE SoCs for the mainstream kinds of applications. So I'll talk to you about some of the innovations that we've brought there and how that can benefit you in your application. So if you're already familiar with Nordic, you may know our nRF52 and 53 series. So I mentioned the 52 series being our most popular. We then brought out the nRF53 series, which enabled Bluetooth Low Energy audio, and also had a number of other applications as it was a dual-core SoC. And then in the past year or so, we've brought to market and have shared a lot more information on our next generation, which are 54 series. And in the 54 series, this is split into two branches. So the 54L series really is taking off where the 52 series left off, covering a similar set of applications, but bringing lower power consumption and more capabilities. And then the 54H series is really a new kind of product with multiple ARM cores, enabling you to build a product with a single Nordic chip that you wouldn't have been able to build before. So today we'll focus on the 54L series, but of course the 54H series, and we have a lot more information that we can talk to you about this on our stand, or you can also find on our website. So the 54L series, if you know the 52 series, it's a very familiar architecture. It's an ARM Cortex. We've doubled the clock speed to 128 megahertz. Combine this with a 2.4 gigahertz radio. The security solution is leveled up from the 52 series in the context of a lot of the changes that we see in the general environment and more people trying to attack these kinds of IoT products. And of course, we integrate with this non-volatile memory and RAM, and we offer a selection of devices so you can choose the right size device for your application. Also in here, we have a set of peripherals, all the peripherals you would normally expect in a device like this, as well as a RISC-V coprocessor, which is enabling some new capabilities that we've not been able to support before, in terms of enabling you to perform real-time critical operations at the same time as servicing the radio, which the ARM Cortex is servicing. So one of the major areas that we've improved is the processing capability and the power consumption of the processor. So the clock speed is doubled to 128 megahertz. So this means that in general we can do double the amount of work in the same amount of time. But at the same time, the processing efficiency has significantly improved. So you'll see that the peak power consumption when the processor is running is lower. So therefore, with half the time under a lower peak current, we achieve a significantly lower overall average power consumption if you're doing the same work on the 52 and the 54L. We've also optimized the radio a great deal. So both the transmit and receive power consumption is improved. So this means in most Bluetooth Low Energy scenarios, you'll be benefiting from the power consumption here. We also have a number of new features. These include channel sounding, which I'll talk to you about a bit later. We're also supporting a new 4 megabits per second mode if you're using the radio in a proprietary mode, so not using Bluetooth. And we also have more better control over the output power, which means you can more finely tune the power consumption versus the output power and connection reliability. So when you add together the processing improvements, the radio improvements, you can see that in most use cases, we get a really great improvement in the average power consumption. So in this scenario where we're doing Bluetooth Low Energy advertising, where you're transmitting across 3 channels and then receiving, and doing this on a 100 milliseconds interval, you can see that for this scenario, we achieve around a 40% reduction in the average power consumption, which is really, really significant given the amount of time that a lot of Bluetooth Low Energy products spend in this state. So to help you understand what the power consumption of your device might be in the end application, we provide you a lot of tools. So here I can walk you through where we can go from the datasheet numbers that you'll find to an average power consumption, how you can see that for yourself using our online tools. So on the left here, we have some of the numbers that you would pick out from our data sheet, like the transmit and the receive current and the standby current. But of course, we need to translate that into what's actually happening on the radio. So here we're advertising, so we're transmitting on 3 channels and receiving for some period of time. So you can see how the datasheet figures translate into what's actually happening on the device. And of course, your average power consumption is the sum of this and then the idle current that's happening in between. So using our tools, you can actually simulate this power consumption online. So the tool you should use for that is our online power profiler. So this supports both our Bluetooth devices as well as our Wi-Fi and cellular devices. So this is a super easy tool for you to use. You can just go to our website, put in the parameters of the Bluetooth setup that you have in your application, and you can immediately compare the expected power consumption when using our different devices. Okay, and then once you've done that evaluation, you probably want to test for yourself. And here we provide a number of hardware tools to enable you to do this. So here we have at the bottom the nRF54L 15DK. So this is what you would use to prototype your application. And then we also offer the Nordic Power Profiler Kit, which you can use with all of our devices. And this is a very low-cost power measurement tool, which works together with our nRF desktop application to offer you a very cost-effective solution for understanding the power consumption of your product on your desk. The Power Profiler Kit is designed to be a very low-cost tool, the kind of thing that any developer can have on their desk. Of course, you can get a $10,000 power analyzer that will be more accurate than this. But the purpose of this one is to understand the day-to-day implications of your software and how that affects the power consumption of your product. So you can try to avoid mistakes early on and optimize things as much as possible. So I can show you how this works in real life. So here, I think the screen might be a bit small for you to see some of this. But you can set the power profiler up in source meter or ammeter mode. That means you can supply the power from the Power Profiler Kit to the development kit. When you enable the power and start sampling, you can see the activity on the device. So each of these peaks will be some radio activity. So you can use this to understand the average power consumption. And then you can also zoom in and inspect the power consumption of specific points in your code as well, to understand where exactly your power budget is being spent. So the aim here is to make this as easy as possible for you to make the right kind of decisions early on in your design. Okay, so now I'm going to switch gears a bit from power consumption into channel sounding, because this is a really new and exciting feature in Bluetooth, which may have applications in your products. So Bluetooth channel sounding, it was introduced for the first time in Bluetooth Core 6.0, and we're supporting channel sounding now on our nRF54 devices. So channel sounding is a new and standardized technology in Bluetooth to enable you to do presence detection and distance estimation. This has previously been possible on Nordic radios, but not in a standardized fashion, which means you needed to have your own product basically on both sides of the link to measure the distance. With this technology now standardized in the Bluetooth specification, it means your device can interoperate with other devices to perform these distance measurements. So it's using standard Bluetooth Low Energy components and hardware. So the same devices that you would use to build a normal Bluetooth Low Energy product, if it's supporting Bluetooth channel sending, you can use to create a distance measurement Bluetooth channel sending solution. It's designed from the get-go to be secure. The aim to make sure that this distance measurement is as reliable as possible and cannot be spoofed. And as this is interoperable and in the Bluetooth standard, it means that you can make a product, let's say an asset tracker, that can interoperate and range with other products, let's say mobile phones, And this support is actually already being added now, I believe, in Android. And of course, we expect to see it on other mobile phone platforms soon as well. And of course, this being part of the Bluetooth Low Energy standard is designed for low power consumption. So the kind of use cases that we see are Find My tags, so finding your house, your car keys, things like smart locks, where the idea is that you can use, let's say, your mobile phone as your access credential as you get close to a door to unlock it. And also more commercial use cases in asset tracking, let's say finding equipment in a warehouse or a shop or a store. And then also in the smart home area, we believe there will be a lot of innovation in more location-aware experiences. So as products will be able to accurately range with other products, including your mobile phone, we expect in smart home far smarter interactions to happen. So let's say rather than having to command a voice assistant to turn on the light in a particular room, you could just perhaps say, turn on the lights. And you would already know where in the house you are and the lights that you are near. So the technology that is used for Bluetooth channel sending is two different technologies. And these are used for different purposes. We have phase-based ranging, where the phase shift between the signals is being measured. And this is the most accurate kind of channel sending distance measurement and is best used in more close-up scenarios. And we also have round-trip timing. So this is where we're measuring the time that it takes for a signal to go from the initiator to the reflector to create an estimation of the distance. Now, these two technologies differ in accuracy and in power consumption. So the idea is that these are actually used in conjunction with each other in the final distance measurement algorithm to create that distance measurement estimation. So we already have support for this in our hardware and in our SDK. So in the nRF Connect SDK 3.0, which will be released this week, we have two samples for reflector and also the initiator. And the initiator actually has a basic ranging algorithm integrated. And we're also providing some PC tools for you to communicate with that initiator and graph the distance measurement on the screen. So you can try this with two development kits to see what kind of performance you get. We also expect there to be a lot of innovation in this area in terms of the algorithms because Bluetooth channel sending actually standardizes essentially how to get the required phase-based and round-trip timing information. And then this then gets fed into an algorithm. And depending on the kind of products you're building, the algorithm that you need may be slightly different to get the right performance. So this really is a new and exciting thing in Bluetooth. If you're working on Bluetooth products, I think it's something you should consider. Whether it's a new kind of product that's dedicated to asset tracking, or whether you're integrating channel sending within an existing product and giving it new capabilities. So as you can see at Nordic, we aim to provide the complete solution. So this is not just the hardware SoCs, but also the wireless protocol stacks for Bluetooth, as well as other technologies such as Matter, Thread, and Zigbee, which all runs on the same hardware. And of course, we pre-certify these to enable you to get your product to market in the fastest possible time. Of course, we back this all up with through our SDK. We have a number of hardware and software tools, such as the power profiling tools that I showed you earlier, as well as mobile apps for you to use in your development. We also have, and really pride ourselves in providing support to all kinds of customers. So it doesn't matter whether you're a small or a large customer, you'll get support from Nordic. We have the Dev Academy, which I'll talk to you about on the next slide. And DevZone is our online support forum, where you can use both public and private tickets to get your questions answered directly from our engineering teams. And of course, we also have local support teams within each country that can support you directly as well. And obviously, the aim here is to get you to market with your product in the shortest possible time. So onto the Dev Academy before we close. So the Nordic Dev Academy is a really, really great tool for you to get started with Nordic if you haven't developed with Nordic before, and then particularly if you're getting started with our SDK for the first time. So we have a number of courses now on the Dev Academy. It's an online learning platform, self-paced and completely free and open access. You can start with an SDK fundamentals course and then specialize in a technology. So you can, let's say you can start with the SDK fundamentals course, then go into the Bluetooth Low Energy fundamentals, where you will learn not just about how to do Bluetooth on Nordic, but also some of the fundamentals of Bluetooth Low Energy as well. So if it's a new thing for you, we will help you get started there. And then we also have an intermediate course. And you'll also find on the Dev Academy, we have courses in the other technology areas as well. And this is something that we're continually building on. And these courses also continually get updated as well. So as things change in the SDK, these courses also get updated so they always remain relevant and enable you to get going. These are really highly reviewed. We've had thousands of customers do these now, so please, I really do recommend them to you. Okay, so thank you for joining. We have time for questions if you have any. Otherwise, we have a stand just outside at the bottom of the stairs. You'll see us straight ahead. And we have a number of demos that we can talk you through, including the Bluetooth channel sounding, as well as a comparison of the power consumption on the 52 and the 54L, and also a cellular demo. Okay, are there any questions? You can grab me before I go as well, if not, you don't want to ask here. Okay, thank you.